Okay, a little review here. Simplify radicals. Okay, simplify the square root of 20. Okay, so 20 is not a perfect square; it is irrational. So then you put a division sign, and then you start dividing. You start at 16. 20 divided by 16. Nope. 20 divided by 9. Nope. 20 divided by 4. Yes. So put that calculator down or whatever. So since I found something it could divide by and it's not a 1, I make the 2 square roots. And I put 4 and 5. Okay. So the square root of 4 is replaced with 2. So this simplifies into 2 square root 5. Okay, square root of 49 is not irrational. So you just write that it's 7. There's no square root remaining because it's a perfect square. There should be no square root at the end. Okay, 21 is irrational. Okay. So you put in the division sign, and then 21 divided by 16. Nope. It's not divisible by 9. It's not divisible by 4. Now, if the only thing it's divisible by is 1, just circle the problem. Okay? Because you can't. Dividing it by 1's pointless. Okay, in this one we're going to be simplifying a radical of 500, but it also has some variables, so I'm going to put operations in it. Okay, and in multiplication what we do is break up that radical, so we have the square root of 500, and then square root of x to the 5th, and then square root of y to the 8th. Okay. So again, when you have multiple factors that cannot be actually multiplied in the same radical, you want to break up the radical so that every factor has its own radical, and then you want to simplify it. Okay, it's kind of like you're doing here, but these didn't have variables inside. Okay, when they have variables, I just make sure every single one of these 3 factors get its own radical, and I simplify them individually. Okay, and then I'll come back over here and make a new radical. Okay, so 500 is irrational. Okay, I mean I know my chart only goes to 400, but if you take the square root of 500, it's obvious that that's irrational. So you put in your division sign and start dividing. 400, no. 361, nope. 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 This is fun. Nope. It's going to divide by 100, we know. Okay, so I got it to divide by 100, and it came out as 5, so I make 2 square roots, and I fill those in with 100 times 5, because that's 500. Okay, and of course the square root of 100 is replaced with its integer value of 10. Okay, so it's 10 square root 5. Now for the variables. If you have a variable with an exponent, you write out how many factors of x you'd have. It'd be 5. And you're going to further break up the square root so it only covers 2 x's at a time. 2 at a time. Now this one here gets its own. That'll be left over. Because x times x is x to the second, but the square root and the second cancel each other out, giving me a full factor of x. And then the same thing happens here. Okay, so we end up with x to the second, 2 full factors of x with a square root of x remaining. Okay, y to the 8th, y times 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 y. So we further break up the square root, and you can break a multiplication, you can break up into as many square roots as you want to. Okay, so y to the second. But that's a full factor of y with the square root over the second power. We end up with just a full y factor. It's going to be the same thing here, here, and here. You should know that by now. So that's 4 full factors of y, and there's no remainder, okay? So in my square root, I put 10 outside and 5 inside. Give yourself some room outside because you got some variables to put there as well. So x to the power of 2 outside, x inside, and then y to the power of 4. By the way, if there's no radical, if there's no square root remaining, then this whole thing goes out. There's no y left inside. Okay, so we got as much of that expression out of the radical as we possibly could. That's what simplifying means. Okay, now you have 2 separate radicals. So I look at my operations. It's all multiplication. Okay, so multiplication, we break the problem down into 3 steps. Okay, we don't need like terms. That's down here where we have a plus sign. Okay, so multiplication, 3 steps. And I'm going to write what they are. Step 1 is to multiply outer coefficients, and at that same part multiply the square roots. Okay, so 5 times 3 is 15, and then the square root of 5 times the square root of 10 is the square root of 50. Okay. Next part, number 2, you need to simplify your new square root. Okay. So, square root of 50. Well, is 50 a perfect square? No, it's not. So IRR, and put in the division sign. By the way, you drop this 15, you carry that 15 down there. Okay, for later. Don't forget about it. You carry it now. You got to remember to carry it down. So start dividing 50. Okay. So 50, is it divisible by 49? Nope. By 36? Nope. By 25, you bet. So 25 and 2. So I make the 2 square roots. I'll just put it in parentheses. Then I put 25, 2. So the square root of 25 is equal to 5. So we replace that square root of 50 with 5 square root of 2. And then the second step is to simplify the outer coefficient if possible. We can definitely simplify it because we can take the 15 times the 5. That'd be 75 square root 2. Okay, and that is how you multiply 2 expressions with 2 separate square roots. Capiche? Okay, next one. We got 2 separate square roots and we got times, but we got this adding thing which we'll circle, and we have to get like terms in order to be able to add. Okay. So the 8's multiplied by a square root of 45, the 2's multiplied by a square root of 125. Those are not like terms, so the like terms, if you don't have them, you need to make a table here and put 8 times the square root of 45 on one side. We'll simplify that, and 2 times the square root of 125 will simplify that, and then hopefully the terms will end up being the same. Okay, so drop this 8 and simplify your square root. So 45 is not a perfect square, it's irrational. Okay, so put a division sign. 45 divided by 36, decimal. 45 divided by 25 is a decimal. 16 is a decimal. And 9 and 5. Okay, so you got that to work, so you make 2 square roots and you put 9 and 5. 9 times 5 is 45. Because the square root of 9 turns into 3. Okay, so next to this 8 we put 3 square root 5. And then of course that turns into 24 square root 5. Okay, so 24 square root 5 plus. Okay, next problem, 100. No, on the next side, 125. That's not a perfect square, so we put the division side. That 2 carries down with whatever we come up with. So 125 divided by 121, that's a decimal. 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 decimal, decimal, decimal. Okay, got it. 25 with 5. So I make the 2 square roots and I put 25, 5. So the square root of 25 turns into 5. So this square root 125 is now replaced with the expression 5 square root 5. Again, the 2 comes from here, and then we simplified that radical into 5 square root 5. 2 times 5 is 10, and then square root 5. So replace that with 10 square root 5. Okay, now the times is still there, but now we have like terms. Just think of it this way: if you get the adding and the multiplication mixed up, if you're confused on that, multiplication's 1, 2, 3. Outsides, insides, simplify that square root right there. Adding, if your square roots don't match, you got to make the table. Well, now they do match. I write the square root of 5 down, and I can now add the 24 and the 10 since they're multiplied by the exact same thing. Okay, 34. Okay, now we're going to continue with those special right triangles. Okay, I'm going to go over 4 examples. Find the side lengths x and y. Okay, I'll find x here and y here. So special right triangle, this is a 30, a 60, and a 90. Now remember, x, y, and 15 are the actual side lengths. Okay, 30, 60, and 90 are the ratios that the side lengths form in relation to each other. Okay, so 30, that's a ratio of 1. 60, that's the square root of 3. 90 is 2. If you get confused, you always have this sheet here to go off of. Okay, 1, square root of 3, 2. Okay, so now across from the 30, put a 1 in parentheses, go across from your 60 on that side. It's a ratio of square root 3, and this is 2. Now we could make some predictions here, okay? I mean, I'm guessing, you know how 1 is half of 2, okay? I'm guessing x is half of 15, okay? I mean, that's like a generalization. So with x, put your x over your 1, and then put your 15 over your 2, okay? And you can do the cross multiplication and division, because 1 times 15 is equal to 2 times x. So 1 times 15 divided by 2. 1 times 15 is 15 divided by 2. 15 divided by 2 is a decimal. It's 7.5. Now I'm fine if you write 7.5. You can write 7.5, or you can just keep it as 15 halves, 15 over 2. Either one's okay by me in this lesson today. Okay, now y. Y, we put y over the square root of 3. Y is the actual value of the side. The square root of 3 is the ratio. Okay. So y is to square root of 3 what 15 is to 2. Okay, so cross multiply and divide, but you can't multiply because you'd be taking 15 times the square root of 3. Put the non-square, put the coefficient value first, followed by the square root, then divided by 2. Okay, then y equals. Now you can divide 15 by 2 and put 7.5 with square root of 3 next to it, or since 15 divided by 2 is a decimal, you can just keep it as 15 times the square root of 3 over 2. Either one's okay. Okay, next one. Now we have a 45, 45, 90. Okay, so 45 is 1, 1, and the square root of 2. So 1, 1, and the square root of 2. So let's find x first, and then y. So let's put x over 1. And then let's go with 6 over square root of 2. Okay, so 1 times 6, doesn't matter the order because they're both coefficients, divide by square root of 2. Now, you're not going to be able to divide until the square root's out of the denominator, so we didn't have that problem up here. But I don't want the square root in the denominator. You need to rationalize it. So you extend the line and put times square root of 2 times square root of 2. Then what happens is this is 6 with the square root of 2 still there. And the square root of 2 times the square root of 2 is 2. You got to know that when you multiply, again, let me reiterate why that happens the way it does, okay? You can multiply two square roots. The square root of 2 times the square root of 2 is the square root of 4. Then the square root of 4, middle school math here, is equal to 2. So that's why you multiply two identical square roots, you just end up with the value under each square root without, okay? And now I can divide. 6 divided by 2 divides evenly, so everybody should be putting that as 3 with the square root of 2. That's your x value. Now the y, okay, put your y over 1. And then you're going to again use your 6 with your square root of 2. Okay, so it's going to end up the same thing. Since it looks the same as it did here, I'm guessing y and x have the same answer. And that makes sense, because y and x are both opposite the 45 degrees, which are equal measurements, so then the sides would be the same as well. So 1 times 6 divided by the square root of 2, get that square root out of there, so times square root of 2 times square root of 2. So that's 6 square root of 2. And that just gives me a 2 value, okay? Now I can divide the 6 by the 2, and that's 3. So 3 square root of 2. Okay, next problem. Another 30, 60, 90. 30's 1, 60's the square root of 3, and 90's 2. Okay. Alright, so 1 across from the 30, square root of 3, across from there, and then 2 right there. I'm guessing, now, 1 to 2, 1 times 2 is 2, so this doubled. I'm guessing if you double 18, that's going to be 36, okay? Let's check and see. So x, put 2 over x, and then the side I know is 18, that would go with 1. Okay, wait a second, I did that wrong. It's x over 2, I'm an idiot. Actual side goes over the ratio. Okay, so 2 times 18 divided by 1. So 2 times 18 is 36, divided by 1 is 36. Okay, y, put your y over the square root of 3. And again, put your actual side that you know, 18 over 1. So you can't multiply those, so you write the 18 and then the square root of 3 divided by 1. Okay, square root's on top, so go ahead and divide 18 by 1, it's 18. So y is equal to 18 with the square root of 3 still there in the expression. Okay. Alright, and then the last one I'm going to go over is 45, 45, 90. So 1, 1, and the square root of 2. That's how that works. So 1, 1. Guessing 1, 1, that's going to be 4. Okay, just throwing that out there at you. Okay, use some common sense here. 45, 45. So the sides that are opposite, if we know that that's 4, that x is probably going to be 4 too. So x over 1. And then 4 over 1. Remember, put the actual given side measurement on top, then the ratio that we got from down here below it. So 1 times 4 divided by 1, well that's 4, and then 4 divided by 1 is 4, just like I said. Okay. Now y. Okay. So y over the square root of 2, and then again use the 4 over the 1. Okay, so in this one we can't actually don't put 8. It's not 8. That's a coefficient. That's a square root. So you put 4 times the square root of 2, and then divide by 1. 4 divided by 1 is 4, and then put the square root of 2 next to it. Makes sense. 1, 1 square root of 2, 4, 4, 4 square root of 2.